So my background, from an academia point of view, applied mathematics and actuarial sciences way back in the day. I've been in this industry so long that back in the day when I started, data science wasn't even a term. So that should give you an idea of how long it's been for me. So back in my day, applied mathematics. My research mainly focused on pro-cyclicality of banking activities. So what that just means is looking at how banks operate and how they extend or exacerbate the cycles, the interest rate cycles, by being too conservative in times when it's the interest rates are high, and being not conservative enough when interest rates are very low, and they kind of exacerbate this cycle. And then also value-based management. Now, I think that's the part from an ROI point of view that I quite like. So that research really looks at what companies should do to really extract value, shareholder value or long-term value for the companies. And what I've done over the years is worked hard on saying, how do we take ML, AI, Gen AI, etc., and relate it to the income statement, related to the balance sheet, because that's the important part in terms of extracting actual value, not just doing AI machine learning for the sake of AI machine learning. Work experience, 16 years in the financial services industry. As you can hear probably from the way I speak, I do not have a US accent, not yet. Still working on that. It's probably going to come in a few years, I don't know. Originally from South Africa, currently living here in North Carolina, in Charlotte. Loving the weather here. It's quite nice. And I've visited Portland and Seattle, and I think we do have a little bit better weather over here than what we have over there. But originally from South Africa, worked there in two of the big four banks, and then joined the Microsoft Solution Partner ecosystem about 3.5 years ago. So obviously in the first couple of years was just banking use cases, credit scorecards, recommendation engines, budgeting and forecasting from a banking point of view. And then joined the Microsoft ecosystem, worked in various industries, agriculture, mining, manufacturing, retail, but always in that sort of what I call predictive analytics. I've started using the term predictive analytics more than anything else, because I think today it's Gen AI and tomorrow it's going to be something else. Who knows? But at the end of the day, it's really about how do you take these predictive methods and apply it to add value and use it in analytics. Yeah, and just some other interests, like my sports, like to watch some sport, like to listen and play music, and the outdoors. If you know anything about South Africa, you'll know that we really like our outdoors and getting outside. So just a brief agenda, kind of unpacking, like I mentioned, ROI and what I mean by that. Then what and why AI, MLOps, LLMOps, what does that mean for us? How does CI/CD and how important is CI/CD for this, for predictive analytics, and then some practical strategies. And in between, I do have a notebook in Fabric that we're going to walk through just with some demo activities, if the demo guards are with us today. So return on investment, I guess the simplest way to put it and to understand it, obviously, it's what's the net return divided by the cost of investment. Now, I found this in picture, obviously, on Investopedia, as it says here. And really just the message trying to get across here is that there's two components to this equation naturally. There's the return that we can get at the end of the day by implementing these models and all these fancy artificial intelligence capabilities that we have. But we need to understand that there's obviously someone that had to do the hard yards, that had to, in this case, create this money-bearing plant, which would be a great addition to my garden as well. But someone had to obviously plow the field and make sure that the soil is fertilized and getting this plant to grow. That's the investment part of it. That's been, yeah, Greg, now I'm with you there. That's the investment component to this. So there's a level of effort. There's either some financial investment that goes into this, or there's a level of effort that goes into this in the form of time, which obviously time is money at the end of the day, but there's some level of effort that that goes into this investment part of it. So the return is obviously not just about the money, but that's kind of what the execs are looking at most of the time. But it could be in terms of efficiency gains, so gaining in terms of the costs, in terms of the time to implement something or to do something, which again, if I can do more of the same thing or more of those tasks in the same amount of time, I can maybe unlock more business value. So ultimately, it does add to that return on investment. It could be something like customer experience improvements. It could be something like risk reduction. I think my world where I came from prior to this, the return on investment came in the form of if we could get the credit risk defaults, if we could get that lowered, that's obviously going to add massive business value to the company. And then obviously the obvious one would be doing something to increase the revenue uplift, which will increase the returns. And then investments, like I mentioned, staff expenditure. I think we just heard about the roles that's available from a data engineering, data science point of view. Trying to find some data science roles and people over the years, I know that those roles and those people are one of the more expensive resources that you need to find. So that investment portion of it, really the biggest part of it's probably going to be some of the staff expenditure, but then also we talk about the cloud and the cloud compute and resources, the infrastructure costs rather, pieces that we need to invest. And then everyone's favorite, I guess, is data quality and cleansing. There's quite a lot of, Greg, you showed the memes. I saw quite a few memes the last few weeks on, the old garbage in, garbage out saying, and what you put in and what you're going to get out. And that's got all these memes. You might have seen it of garbage going into a Gen AI application. You get this fancy unicorn, but it's still garbage. And garbage going into a machine learning model still comes out as garbage. So there's a lot to be said for the level of effort that needs to go into data quality. And I think just looking at the type of work we do, clients we work with, what we see out there, data quality is an issue for a lot of companies, I would say. There's a lot of things to overcome. It's not just that AI is going to solve all those problems, AI, machine learning, LLMs, etc. If you plug it onto garbage data, you're still going to get a garbage answer. It's going to be an LLM. It's a generative answer, but it's still going to be a garbage answer at the end of the day. So there's a lot of investment that would need to go into the data quality and cleansing. So really, how do we improve ROI is, well, how do we obviously increase the return or decrease the cost of investment, or both? I mean, ultimately, just the basic math of it is if we want to reduce the return on investment, we push down the net return, or we increase the cost of the investment, or both. And this is really the way we look at it from this perspective, and unpacking that a little bit further. So just what makes the return decrease over time, and now specifically if we look at it from the lens of AI, machine learning, predictive analytics, as I mentioned before. Well, believe it or not, one of the biggest reasons you'll never get the return on your models is because they never make it to production. There's some stats I'll show a little bit later, but some studies show up to 80%, that's 80% of models. I've heard a lot of 70%, but let's say 70 to 80% of models built never actually make it to production. Now, if you think about it again, about the investment, standard model, typical model, let's just call it a propensity model for take up or something similar, can take you anything between 6 weeks to 12 weeks to build. So if you have 12 weeks spent by an expensive resource on potentially expensive equipment and infrastructure, and it never makes it into production, that's a problem. That's an issue. And there's some practical things that I've seen over the years, which we'll discuss in a minute here, of why these models never make it to production. But that is one of the biggest issues. The obvious one, I guess, but just to reiterate that, is the lack of alignment to business objectives. So if you are working on models that's not aligned to anything that you want to do from a business point of view, or if it's aligned to some objective which is not maybe a primary focus for the business, and you're working on that and it's never going to add value to the actual goals, that's also not going to increase the net return. We're just going to spend resources, spend time on things that's never going to get used. Data quality I mentioned, garbage in, garbage out. There's an interesting one. Again, back to my earlier days. I don't know if you guys have ever heard of Tom Davenport. He wrote the book Competing on Analytics way back in I think the early 2000s, if I remember correctly. When I started out working, one of my executives gave me that book and said, we want to build this. We want to get into this analytics space. That's when analytics, I guess, was a similar term to what Gen AI is at the moment. Very new. Not a lot of people knew what it's about. And one of the big factors he identified back then was that's going to make analytics not add value is lack of leadership support. So it's quite a critical aspect of it. You'll see here that some of these bullets are obviously in bold. The bold ones are the ones we're going to discuss because that's for me relevant to the how do we solve this using the DevOps culture. But I thought I just mentioned these ones as well as some of the things I've seen over the years that can add to the non-value adding. And then the final bullet on here is the model is obsolete by the time it gets into production. Now, what that means is by the time we're actually done and we get to production, the data has drifted, the data is not valid anymore. And I've worked in environments where our average time to implement the model, for example, a credit scorecard was up to between 12 and 18 months. And I see that's kind of a standard within the industry. And that's really due to a lot of regulations and a lot of regulatory hoops to jump through to get that into production. But in some cases, you get to that point by the time you actually implement the model into production, you basically have to rebuild it because it's not performing the way it did when you trained it. It's not performing the way it should. It's not performing acceptably anymore. Like I mentioned, the data might have drifted, and you really basically spend a few months building that model, and I have to redo all of that stuff all over again. And sometimes that cycle can just continue and repeat itself. From an investment point of view, what pushes that investment up unnecessarily? Constant model refactoring in different environments. So what that means is what you'll find often is the data scientists or the analytics quant or whatever we call them, they are working in an environment, and that environment is not the same as what you have in production. You think about it again, I don't know if any of you've ever heard of SAS. SAS is one of the major tools, oldest analytics tools available. Again, a lot of the banks are really tightly integrated. I think some of the retailers as well. A lot of times you'll build those models in SAS, and then by the time we want to implement that needs to now get implemented in a different environment, in a Java-based environment, as an example. I can tell you stories of where we've sat down and tried to reconcile the SAS answer, because now we're testing this, we want to implement it, we want to see if we're getting the same answers in the production system as in the training. So we want to reproduce the prediction, the value. However, SAS maybe does rounding different than what Java does. And the amount of times we had to go back and forth in conversations where the one system gets 0.999, let's 569s, and the other one rounds it to a 1. And it just breaks everyone's momentum then, because we cannot reconcile these two predictions, and we cannot figure out why the training one is not the same as the production one. So stories like that slows you down, completely breaks the momentum, and again, maybe leads to models being obsolete again because it's drifting over time. Poor collaboration resulting in repeat work, specifically on features. Normally, if you look at the features that we ingest into the model to select from. So what I've seen in the past is same feature set. Let's say there's a feature that we create that takes a date and creates or tells us whether that's a weekend or a weekday, because that's an important feature normally, especially in retail. We want to do demand forecasting, for example. And you've got 10 data scientists working on these demand forecast models. Each of them could use a feature like that, where we say whether it's a weekday or not. And they all reproduce the same set of same code for that feature 10 times over, instead of working together and just sharing the code base in a proper manner. I'll just put that disclaimer out there as well. But they don't share these code bases with each other, and they keep reproducing these answers 10 times over. And what sometimes what happens, maybe not in the weekend case, but in some features, you start getting different versions of this feature. Yours is slightly different than mine, but this is the one I like. At the end of the day, that just causes rework, a lot of repeat work. And then, as I mentioned, sharing it in a way, not having a platform to share that code base, or to share that knowledge with your teammates in a proper way. And a proper way is not always sending code bases in emails, which also happens sometimes, which is not ideal. Just also on collaboration, collaboration is not necessarily always working. We're all working in the same notebook, or we're all working on the same code at the same time. I think we all understand, branching strategies and having a proper branching strategy in place so that we don't overwrite each other, we don't trip over each other's work, or we don't delete someone else's work unnecessarily. Having a proper collaboration framework in place could reduce the investment and not push it up unnecessarily. And then poor deployment frameworks comes back to the CI/CD discussion earlier. How do you deploy? Is it a manual deployment? Do you have your dev, UAT, staging, QA, whatever that middle environment is, and prod? And how do you promote these code bases through these environments? Is it a manual rework, which happens? Maybe the dev databases or data tables and table names, etc., is not the same as in UAT, it's not the same as in prod. And you cannot simply automatically just deploy these code bases throughout the environments. You have to manually refactor them in each of these environments. So think of it, every time you make a change, you have to manually go in and make those changes. That's really, really not ideal. And that's going to push up the investment, because that's going to push up time, resources spending time on those things, and the cost goes up. So just to unpack this a little bit further, like I mentioned, models never making it to production. Scary stat, if you ask me. If I look at that, that's for me not a good thing. And if you can reduce that, you'll make a lot of winnings. But 70 to 80% of models never making it to production. So data scientists, what happened? Why does this happen? Often is data scientists working on machines on their local, working on models on their local machines, and no infrastructure to deploy them. Now, the issue with that is, if they're working on it on their local machines, it works on the classic, it works on my machine, it doesn't work on your machine. And why does that happen? You don't have the same environment set up, you don't have the same library set up, which becomes a challenge, and it's difficult to port it. You might be using something that works on your local machine, but cannot work in your cloud environment for some other reason. And that becomes an issue. And otherwise, models also being built, that's something you see often, is models, data scientists working on things on the side because there's no clear guidance, there's no governance process on what you should be working on. So they obviously start experimenting. It's a creative a creative person normally that becomes becomes a data scientist, because you have to have some sort of creativity within your psyche, because the whole process of building a model is constant experimentation and trying to be creative with the features. So these guys and girls normally want to be creative, want to build something. So they'll start working on these things often. And if they don't have clear guidance, guardrails, clear direction on which projects to work on, they could be working on something that's really irrelevant for anyone in the business. Models obsolete, like I mentioned, by the time we get to production. I don't know if you noticed in Azure OpenAI to Azure AI Foundry now, which let's call it the last year and a half. I think we went from roughly about 20 models, 20 LLMs within Azure OpenAI. There was the basic GPT-3.5 Turbo, a few versions of that, the text embeddings models, and yeah, I think there were about 20 if I remember correctly. There's now close to 2,000, right? There's so many more LLMs that's deployed. So by the time you get to production, if you take 6 months to build something and get it into production, you might have a bunch of other models that's already being deployed, and you need to have an environment that helps you to quicker get these things into production, number one, but also something that's enabling you to quickly make changes and swap in and swap out different LLMs or different model techniques, so you can get to that, so you can stay up to date with the latest developments.
Quick question for you, Hennie,
Yep.
from the chat, from Sam. This
Yes.
Fabric, Databricks, Snowflake model sharing, and MLOps, does that help solve this problem?
If you set it up, I think that's the point. Yes, Greg. If you set it up, Sam, in such a way that you can shift out models, and I'll show you just a small example in the Fabric notebook that I have. But if you set your MLOps structures up in such a way, and your modeling process up in such a way that you can quickly shift in and out. If the GPT-3.5 landed, now GPT-4.0 lands, you can just shift them, rip out and replace it with a 4.0 and run the models and see what happens. That's where it's going to help you with that capability. It's not obviously going to solve it end to end always. Unfortunately, these models also change and become smarter or become more complex because they have more function callings that they are doing. So sometimes some of your code might not work exactly the same. You might have to refactor a little bit, but at least it's not starting from a blank slate every time when a new LLM comes out and you start the whole process from the beginning. If you have at least some base that you can work with and get these things in much quicker, that helps. That alleviates some of that time pressures. I hope that answers your question, Sam.
Yes, it does. Thank you.
And to the point, I think, MLOps and the way we like to use MLflow in that scenario and MLflow's capabilities to do our MLOps pieces, like you said, the Databricks, Snowflake, etc. If you have that capability, which it should, you can actually do that in those environments as well. All right, so I mentioned that. So typical model to implement 3 to 6 months to get it from start to finish to implementation into a production environment. Some regulated environments, 12 to 18 months. And really that comes down to some of the reasons being different coding languages to build versus integrate. Back in my early days, before APIs, I think was as big as they are now, and I think this is now probably 10, 15 years ago, we started exploring things like PMML. I don't know if any of you've ever worked on PMML, predictive model markup language. So it's like HTML kind of for predictive models. So we started exploring using that instead of literally building the model in your environment that you're building the machine learning, refactoring that completely into a Word document or an Excel document, etc., and then having to code that up into the production environment. So we've moved along quite far from those days. Nowadays, if you can deploy an endpoint and that system that you have can integrate with that endpoint, you've got a much easier transition. And if you think about kind of a microservices architecture mindset around these things, where everything sort of talks to each other with APIs, that makes the deployment time quite a lot shorter, which again adds value. I mentioned the different infrastructures or different coding languages that where you run the training versus the development. And then another problem that often pops up, and often pops up too late, or the realization pops up too late, is we are in our data science environment, we're in this experimentation environment, and we're building, and it's going well, and everything is great, and we get the best model, and we're using all this data that we have available. And then once we want to port this thing into a live environment, into production, we realize, let's say for real-time serving, for example, we cannot, for some reason, orchestrate or get some of this data that we need for the model inference, which causes obviously a lot of rework, or causes a lot of issues in terms of having to rebuild the entire thing. Or alternatively, having another project that takes a few months to at least get that data available. All of these things, again, leads to delays that can lead to model being obsolete, having to be retrained again, which is not ideal. Repeat work. Like I mentioned, I've seen this quite a few times in my life. Same feature set, same set of variables, built 10 times by 10 different data scientists, not having, not having a code base that can be reused and share, and that code base being shared amongst everyone so that all can reuse it. Unfortunately, in model building, as the stats shows you on the right, that's normally the reality of it. The 80-20 rule. The bulk of your time is not spent on the actual model building and model training piece. The bulk of your time is actually spent on that feature engineering part, the data cleaning part. So if you can reduce that, and if you can make that a more solid process, that's going to reduce the time to implement, reduce the time to production, and then obviously going to increase the ROI. Model training is repeats. So what I mean by that is quite often what you find is if you don't check these things into a repo, it happens. You build something, you're busy with this model, you're getting into a good groove, and then there's something that sidetracks. There's another project, there's a fire to get sidetracked on that thing, which takes your attention away. Once that's done, you come back to your model, and now it's a case of, I can't remember what I did here, I can't reproduce the results anymore. I did something, I was experimenting with something, but I can't reproduce and get back to those results and those metrics. And then we kind of start over again. So having those sort of practices in place really helps with reducing that negative impact. And then poor development frameworks, roughly in terms of stats I found just in researching for this, it's up to 10 plus times slower to productionize something manually. So meaning taking it manually through the environments instead of just having a deployment pipeline, which you can kick off and it syncs the UAT and or prod environments. So having an automated deployment environment really adds a lot of value. So I guess in summary, in terms of ROI, if we can ensure that we work on models that's needed, not something that's an experiment on a local machine that no one knows about, which happens a lot. We make sure that we're working on stuff that can be integrated. So the data is in production. We have the capability to integrate it with production via APIs and not manual processes. We use best practices that ensure the reuse of code and the reduction of duplications. And we promote these environments through using automated pipelines instead of manual deployments. We should see that ROI go up. So some of the key focus areas that I've found that's, practical things that we can look at. And the first one, I think Steve and the guys, at least in Omnidata, have heard me say this quite a few times, and they probably know this off by heart, is when I talk about machine learning models or Gen AI, LLMs, AI, whatever piece of predictive analytics that you're looking at, is that you need to treat these things as a company asset. So, and what I mean by that is, if you think about, if you're a manufacturer, property, plant, and equipment, as an example, is an asset. You probably want to have a registry of those assets. You probably want to know where each of them are. You probably want to know which, what versions, what kind of machines they are, what can they do, what can they not do, who's operating these things, where are they physically located. That's kind of the mindset that, you would want to take with an asset. I mean, an asset is obviously, from a business perspective, something that you use to generate value. And really, you need to treat these predictive models as company assets. You cannot treat them as just experiments and side of the desk things. You really need to take a strong stance on these predictive models, on these assets, and treat them as a first-class IT construct, in the sense that the same way you would look at your ERP system as an example. You think about, you've got Dynamics, F&O, or Business Central, whichever one you have in your world. There's a clear plan for that thing. There's a clear owner for those assets. Normally, there's someone that looks after it. There's a governance process. There's process of how we make changes to that systems. There's a roadmap normally that says we're going to have this system, we're going to sunset it at some point, replace it with something. There's considerations around the security of it. And really, that's how you should treat your predictive models. If, like I mentioned in the previous slides, it's expensive resources working on these things, there's so many things that could lead to the reduction in ROI from these machine learning assets or from these predictive analytics assets. Why would you not treat this thing as a proper asset, as a proper company asset? There's another slide I normally use, I maybe should have added it here, but another slide that I normally use that shows market capitalizations and value for companies over the years, over the decades, in the 80s versus now. And you can clearly see in the beginning, in the 1980s, 70s, 80s, the bulk of a company's value was determined by physical assets. Like I mentioned, property, plant, equipment. The bulk of assets or value these days, in the, let's say, 2010s, is determined by intangible assets. And those intangibles includes things like IP, for example, and I think this sort of plays into that realm where you start building IP for your company. And really, if you treat this as an experimentation piece of work, something that's on the side of the desk, we're working on it, but we're not really focusing on it. We're not putting enough attention to it. There's not enough leadership buying to it. Then you are going to run into ROI problems, because you're going to work most likely on things that's going to be irrelevant and have resources running models and creating models that's not going to be used. So it's a careful balance to make sure that we get the ROI we want. Go from an experimentation mindset to a scale mindset. There's a nice book. I don't think we can get the article online. I'm not too sure, but if you want to, have a look at Thomas Davenport. He's the guy I mentioned earlier that wrote the book, Competing on Analytics. He had one of Harvard Business Review's top 10 reads on AI. I think I bought this book in 2023, so it must have been for the year 2023. There's quite a few good articles in that book if you want, but the one that they wrote, the title was "Stop Tinkering with AI," and the message is not really to say stop messing with it or stop looking at it. Don't stop tinkering with it. The message was stop treating it as an experimentation. Take a large business process and really apply your mind. Take an asset approach and apply your minds to get the proper value from it. Which is a scary prospect for most companies, I know, because you're starting to mess with one of the bigger business processes in the company. But if you want to get scale value from this, you really need to look at it that way. If you're just going to constantly do experiments on the side, nothing ever goes into production. Again, back to the previous slide, your ROI is going to go down, not up. Ensure the integration frameworks are in place. I think critical message there, which I believe should be fairly obvious in this scenario, because you want to have that ability to quickly integrate and make sure that you get these things into production as quickly as possible, and as automated as possible, not a lot of manual work. And then other key point that I think is critical in this is like this, what this talk is about as well, is using the DevOps philosophy, using that for machine learning, AI, LLMs, with your CI/CD capabilities as the how. There's a great book, if you haven't read it yet, I can highly recommend it, The Phoenix Project. I'm not a big fiction reader, but this book is written as a fiction, as a story, but it's all about how the kind of DevOps would work, how the development teams and operations teams were not working together. And, there was a lot of fires, as you can see here from the picture. There's not just a fire, it seems like there's a pot of lava on top of all those servers. It's going to just melt everything. And really this picture depicts the story as well. The classic, there's the wall and there's the developers or the business people, and they throw it over the wall to the technical teams to implement, and how everything goes wrong. So the story really starts off with there's so many fires, and the guy starting to figuring it out and seeing that having the developers and the operations guys working together, that's where we start getting a lot of value. So I highly recommend that book if you have time, and you want to read something new and you haven't done that already. And then I'm going to step across into the demo, but I think before I do that, just pause here and see if there are any questions at this stage. Does it make sense? Does it resonate? Yep.
Yeah, no, I'm just going to say, any questions? Is everybody still awake? This is the fun part. Here. Okay, awesome. All right, I think they just want you to get into it, Hennie. Let's do it.
Awesome. Sounds good. So I think just some practical things that you can do. This is just a demo notebook. There's maybe I can share that, Greg. You can maybe share it with the group as well. There's a Microsoft Git repository also on MLOps. As I mentioned, a lot of that in that Git is more focused on Azure Machine Learning, and I think Databricks more so, and not a lot of Fabric stuff, but also good resource. And some of the stuff that I used over here really came from that. Again, like I mentioned, there's so much that you can do in terms of DevOps for machine learning or DevOps for predictive analytics. We cannot go through every single thing at this stage, but I'm going to give you some practical things that we normally do in Fabric to sort of help us with this process. So what we have here is just a code base that's going to help us just show what we do with MLflow and how we use that. I'm going to show you quickly how we normally would set up the workspace environments, and obviously the linkage with Azure DevOps for managing the model, the pull requests, the commits, and so forth. I ran this thing in a few minutes ago. It's obviously not shut down. I can run it again, but I think the results are obviously showing in the notebook. So at the first junction, naturally just some MLflow libraries that we install, and then importing some libraries. And normally I try and demo here by just making a change there so we can see it in the DevOps, but today is the 26th actually. We can do that. This is just, I put this here to showcase how it changes when we go to Azure DevOps, and you can see the kind of side by sides. So just a sample data frame, and you can see this is really sample data because that's basically just generating some random numbers. Is this, by the way, is this zoomed in enough? Is it big enough? Sorry, I should have checked that up front.
Yeah, it looks good.
Looks good. Awesome.
Yeah.
So just some random numbers that we generate, and the typical, and I'm taking it through from a machine learning point of view, and then we'll have something along at the end also on a generative AI solution, just to showcase similar principles. But basics of models, the take-up model that we're trying to predict yes or no. So you're going to run some sort of classification model in this scenario. And what I just did here is created two features, an X1 and X2, and it just generates random numbers for us. And then I created something for time series forecasting if we really wanted to go into that level of detail. And this is for one product, widget 1, 2, 3, 4. So that's our sample data frame. And this is really where we get into the feature discussion or the reusable code that I mentioned before. So kind of a good practice that I've used over the years is, creating a user-defined function. And what you can now do is obviously check this user-defined function into a code repo. And someone can just use this piece of information. And this function just basically takes a date and would create the month of year, week of year, which quarter, which day of the month, also how many days in the month, what's the week of the month, is the first, second, third one, days in the week or the day of the week, etc. So it just creates some time series based features. This is a sample of generic demand forecasting type of features that you would get in any type of demand forecasting model. But writing it in such a way that anyone else, as long as their data set has a date, they can pass that data set through this function. They can just, in a few seconds, generate a couple of features. This is obviously less than about 10 features. What you typically would get in large organizations is you would get thousands of these. So in some of the organizations I've worked in, we've had a feature set or feature store that's got about over 10,000 features, over 10,000 different variables that you can generate for data. So that again becomes a problem to manage. 10,000 features, then to give everyone a code base to do that becomes difficult. So typically what we would do is use something like this. Use some user-defined function which you can just run, and it just quickly generates those features for your data set. This piece of code naturally just, I'm adding those features so we can see that we go from the sample code base that we had, sample data frame that we had, and we're now producing the time-based features on the side here. And that was just to set up some data for us to work on. So this is really where the experimentation portion starts becoming relevant. So this is now where MLflow comes into the picture. And what we're doing here is we initialize the experiment. And for those of you that have never worked with MLflow, so we want to set the experiment. So we want to give it, we're saying we're starting with this experiment, we're giving it a name. The best practice for me always has been, user, what are we doing? So in this case, we're doing an MLOps demo, and that's the experiment. And just at least put a date. Obviously, I ran this 2 days back. We would just change that to today's date or whenever that piece of work is starting. So if we are building a churn model or a fraud model or a take-up model, if you unpacked it in your agile process and you've now created the feature list, you're saying, here's a churn model that we need to build as part of this process. You might add that starting date over here, just so something that you have a timestamp for going forward. This code, simple enough, just takes the X and the Y's, creates the fields that we're looking at. Take up is the target variable, and our X1 and X2 is our input features. We just split it. And once we get into this level, this is now where we say, let's start with MLflow. Let's start this run. So starting the run, and that's our first run ID. So think of the experiment as, the experiment is we want to, if you want to take it into let's say a cooking analogy, the experiment is I'm trying to bake this, an apple pie. That's my target. That's my goal. I'm trying to do this experiment to build that. So like I mentioned, I'm trying to build a churn model, or I'm trying to build a fraud model. That's the ultimate target. The runs in this scenario are my different attempts. So I do attempt 1 at this apple pie, and it's so good or it's so bad. Then I try something else. I change some of the ingredients. I try again. Those are all your runs. And what we do over here is we start the run. We're saying, okay, so let's keep going. Best practice for me normally with MLflow and with these things is tagging. Set as many tags as is practically possible and practically usable. But we don't have to have 1,000 different tags here, but it does help because somewhere down the line, you're going to build this model, implement it, and we're going to move on to something else. And somewhere down the line, that model is going to drift and we're going to have to come back to it. And then it's normally a case of, okay, so who did this? Let's figure out what happened. Maybe that person left, it's not an employee of the company anymore. And you need to figure out what's going on there. So it's really good practice just to set, who was the author? What are we looking at here? What version of the data are we using? And you can think of, practical things that make sense within your company that you want to tag. These tags are, you've got free reign in terms of what you want to put there as a tag. And you can also obviously make it a variable so it automatically and dynamically changes. But definitely good practice to at least have some tagging. It's going to save you time, like I mentioned, when you have to come back to this model after a few months, after a few years, and revisit it and see what happened and make sure we understand it. Just a simple XGBoost in this case. And then logging the metrics. So when you log these metrics, depending on the model, depending on the type of model, in this case, it's a real simple accuracy metric, but that could be your F1 scores or your precisions or your specificity, etc. If it's a more regression-based model or neural network, you'll have some other measures that you want to, or metrics that you want to log. And you can definitely add more here. I just put the 1 year from an accuracy point of view. And then finally, once we're done now we want to log this model. Why do we want to log this model? Because once we've logged this model, we can actually reuse it. We can come back to it. We can surface it in other environments. We can leverage it again. We can just recall that run ID, pass it the information that it needs to produce a prediction, and we output that. So really practical way to log the model. Using MLflow's capabilities, what you can see is a lot of MLflow native capabilities, which makes it a lot easier to do these sort of things. But it is going to save you time in the long run and save you headaches going down the line. Something we like to do is also just capturing those run IDs, and I'll show that in a second here. But once we're done, we end this run. So this is our experiment. So these are all the changes that we've made. And typically
quick,
what you
Hennie,
yeah, go for
really
it.
quick, Hennie, I wanted to bubble up a comment Sam made, and I think it was a good one. When you were talking about appending, you could also use git commit hashes or git branches, right? Is that supported in Fabric?
The git branch names, or which one? The git commit hashes. It's a good question. I'll check for you. I haven't used that before myself. So Sean, I'll have a look for you if you want.
Up to you. I'm new to Fabric, but as far as I know, whenever people are working on code bases, VCS is always a great way to tie to versions.
Yeah, I'll have a look for you. I'm pretty sure. I mean, I can't imagine why, and if it's not supported, probably it's coming in, probably in the pipeline to come at some point. But yeah, it's a good point.
Yeah, you also mentioned CI/CD, so it would be essential at that point.
Yeah. And I'll show you what we, from a CI/CD, how we set it up using Azure DevOps as well with the pipelines in Fabric in a second here. But I'm pretty sure you can do that then, yeah.
Cool. Thank you.
Awesome. So this is where you would run those experiments. And really, as you can see, just logging all that information so you have that going forward and you can actually unpack that. This piece over here just is where we store these run IDs, just making sure we have them for future reference. And then obviously something that I really like from a from a Delta point of view is, writing these tables out. So what we would normally do is we'll take this experiment, take this run, take the training data that was used in that run and just output that as a Delta file. Why is that important? Well, it becomes useful if you want to now say, you've now run through these different versions of the models, you've now retrained and you've evolved and iterated on the model, and you're now on version 10 of the model. But now we want to say, well, let's have a look at this model version, this latest one, but with the previous feature set or different feature set. Maybe we change the version or change the logic of a feature. We're not calculating it this way, we're not calculating it in a different way. But now we want to see that impact with the latest model. So when you have these Delta files, you can obviously, I'm sure you guys have worked with Delta files, you can obviously go back in versions and start playing around with that and saying, well, let's run the latest version with a previous or very early version of the features, or the other way around. Take the new features running against the previous version of the model. All of those things becomes really useful when you have this stuff saved as Delta files. Fabric, just to mention, that comes natively with, I think the ML flow comes with a UI, and that's natively built into Fabric. So once I've run these experiments, you will see this run name and the typical coming up with these very interesting names. A bright steel pan in this case, which sounds very intimidating. But it logs these runs for you. You've got a nice UI that you can leverage. You can obviously export these metrics. Now you'll see the different runs that I've had in the past here, each of them with their own names. And what's nice is it gives you a bunch of information. Who created this model? When was it created? What was the accuracy metric? Again, in this scenario, I only logged the one metric, which was accuracy. If you've got multiple metrics here, you can log all of them, which means you can quickly, if in a few months' time you come back to this model, you can quickly reproduce those results and see, am I still getting that same accuracy level, yes or no? If you were to log the parameters, I didn't log any of them, but you can log some of the parameters here as well. The model type, so that was all the taggings that we created, and you've got your run IDs at the bottom here as well. And you can go through these lists and see what happens. What's also nice, obviously, is it gives you the underneath the YAML files, the requirements files, etc., the model that you can leverage if you wanted to start deploying these things in a real-time or an API environment. You could use these models, these files as well, automatically generated for you. And then I didn't display this ML data frame, but that just showcases, I'll have to run this everything. I'll maybe see if we get back to that real quick. That just displays the different versions of the model, the run IDs with the features that we use to build the model. Then what we normally would do is, as you can see right here, is I've now played with this. This is my experiment name, like we mentioned. This is what we're trying to build, the churn model or the fraud model. And what I can do is I can say, well, give me the latest run ID, or if you just extract everything from what's saved in MLflow for this, you can see quite a lot of information is saved out of the box. So you've got your experiment ID, and in this case, you will see that those are all the same. Again, we're working on a churn model, or we're working on a fraud model, but we have different run IDs. And it's really easy to go back into these, find a particular run ID. If I want to see what the accuracy metric was, if I want to see who built it, if I want to see what type of model was built, so logistic regression, all the tags, all of this information is available. And what you can do naturally is, if you wanted to build some dashboarding on top of this or visuals on top of this, that also helps. So what we've done over here, I've just limited it, but if you look at this gives me a nice view over time of the accuracy of my model. Now remember that my accuracy is based on random numbers generated for my input features. So this accuracy will be all over the show. But as you can see, I can quickly track it. I can set a benchmark, this yellow line as an example, and say, well, if my accuracy drops below a certain level, trigger a retrain. If my accuracy drops below a certain level, inform someone so that they can go have a look. I can also have in here champion challenging or champion challenger views. So if my champion model that's currently in production is sitting at a whatever percentage accuracy level, I can run these experiments and compare it to that and say, well, this one is now better than the champion model, so let's push that one into production. So again, you can play around with a lot of things when you use MLflow, when you log all of this information. You can have a look at some stats and make some decisions. If you think about it, some worlds the models can be retrained. If you think in the airlines industry, I think is maybe a good example, where they have dynamic pricing going on, reinforcement learning models that's running constantly, having a look at the demand and making price adjustments. Those models get trained very regularly or retrained very, very regularly, versus something like a credit scorecard in a bank. That thing needs to sit there for quite a while before it gets retrained. So if it's a shorter turnaround time in terms of retraining, it would be quite good to have these sort of stats over time, so you can have a look at what's happening with the models as we go.
So quick question before you go to the next portion.
Yep.
Sean was wondering he saw that there's an author for the data frame as an Azure user, but the tag for the author mentions a string as the developer. Are there ways to integrate Azure identities and credentials into tags as well? Maybe with the Python API, but he's just wondering about the implementation overall.
So Sean,
can you use Entra?
Yeah, when you say the Azure identities, I'm just trying to understand what would you want to do with that? Is that just to not to manually, but to dynamically rather get those Azure identities and kind of populate them within this table?
It's so that way, well, technically each of these pieces of data will be associated with somebody working on this data. People who publish this data may be inside of your forest or any part of Azure. And if you were to try and track this down and say that you wanted to track what version it was, then you could directly go to that person's identity rather than have to like look up an email after you find out the string of what the tag was and then track down who the user was. If you could just have a way to directly integrate the identity, then it would be easier to establish who owns and controls that data.
Yeah, I think to the point on the Python API, if you can probably just build I mean, this is sitting in a data frame, it's available. You can just extract the information and build some manual process to check that user and leverage the Azure identity and all the information that you have in AD. So I'm pretty sure it's possible. I've never done it, but I'm pretty sure you can do that because you have the information here. And again, I think what you also, I must just check what you get, but there are some standard get workspace. I forgot the exact naming convention now in Fabric, and Azure Machine Learning works similarly, where you can get the actual user information from the workspace, who's got access to this workspace, what workspace is it. So there might be a way to dynamically populate that as well and link that then up to something like Azure Identity as well. But yeah,
right.
I've not done that, but pretty sure you can do it.
Would you like to know the purpose of why I'm asking that question?
Sure.
Well, in cybersecurity, for example, there are points where people are talking about contaminated data, or if there are instances where someone intrudes into your framework, right? If somebody comes into here, if you had a way that was solid as to like, say this is this person who is editing this data every time, and then it would be like immutable, or in some cases like you couldn't modify it and it was like solidified into your identity access management, then it could technically improve security.
I gotcha. Yeah, that makes 100% sense. I think that'll be a great use case for something like that then, yeah. Because I think if you look at this specific username, I mean, I did not populate that myself. That came from Fabric and its workspace settings. So yeah, that's a good point. You could, I guess, build flagging or not tagging, alerts based on this information, like you mentioned. If there's constantly the same user that's doing something, you can alert someone out of this. That's a great use case. I like it.
Thank you.
Awesome. Yeah, so once we've now run these models, normally we've experimented and we've got our accuracy and we're happy. We normally want to load these models. So now we're creating some data, again, some random data over here in terms of X1 and X2. And these data points is just now, think of it as now we're inferencing, we're using this model, we've built it, we've trained it, we're happy, now we want inference from that. So again, it becomes easy because we've created our run ID that we're happy with. We just load that model and that happens right over here. So now we go into MLflow's load model. We know what the run ID is that we want to look at, that we were happy with. That's the best one. And we can load that model and apply it to our data and get the prediction. Again, this gives you flexibility in terms of testing different run IDs. If we wanted to test the last 3-4 versions of models that were in production, we can do that fairly easily because we have the run IDs in our data in a Delta table. We can also go to this particular version of the Delta table, apply that, and get the results. So that makes it a lot easier for you to keep track of these things. I know it looks like a lot of coding and a lot of content that needs to happen, but the fact that you have this documented, the fact that it's in these tables and it's Delta, it's versioned, etc., really helps with making sure that we don't waste time on these things and we don't lose focus when we do it. Yeah, this is just another piece of code in terms of the model version. I don't think I need to show that again. I've actually shown that piece as well. And then, like I mentioned, if you wanted to retrain or not retrain, if you wanted to do training with different data versions, you can, again, because we logged it at the top, we logged it when we wrote up the experiments, you can again see that. So just from a generative AI, I think like I said from the beginning, it's predictive analytics or DevOps or predictive analytics, whether it's for machine learning, for AI solutions, for LLM-based solutions or Gen AI solutions. I think similar sort of concepts that applies within the Gen AI space, like we said, 20 to about 2,000 large language models that's deployed. You constantly want to test. You build something that's in production that maybe uses a GPT-4 mini, and now GPT-4.5, for example, comes out, and now we want to test that model, or we want to compare it to our old version of GPT-3.5 Turbo. So you want to set up again the environment so that you can quickly plug in and plug out these models if they are deployed. Now, this obviously assumes that you've got it deployed in the Azure AI Foundry environment, and you have an API key and you have an endpoint that you can call. So when we look at Gen AI solutions, though, slightly different functionalities that we need to use compared to machine learning. So MLflow, again, makes it very easy for us to do this. We often use this PyFunc method within our models. So we'll build a class, as you can see, a class object. In this case, it's a chatbot LLM. We initialize it, we load the context, in this case, just being the endpoint and the version and the API key. Obviously, I put these into an environment file, not to share those sort of things within the code bases. And this is a real simple chatbot LLM. Obviously, if you build something more complex, there's going to be a lot more code here. This thing just really simple. I just said to you, you're helpful assistant trained on product manuals for technology products. Now, where it becomes a lot more complex is if you wanted to, let's say, build something, an agent, a support agent that can answer questions, technical questions, if a customer comes in with a query. And you maybe want to give it examples, say, here's some examples of questions that we've gotten previously and typical answers that you can give. That's where you start adding a little bit more of the RAG capabilities, and then that RAG capabilities can obviously get a lot more complex if you start adding indexes and so on. But just for a simple example over here, system prompt, your helpful assistant on technology products, and things like temperature as an example, things like I mentioned, like the LLM, things like the max tokens. You might want to build something, integrate it, and then start testing it and say, okay, well, if the temperature is at 0.3, I get these answers and my users are very happy. If I push this temperature up to 0.7, the users start complaining because the answers are too random. If I do max token 500, I constantly get answers that are too short. If I do max tokens of 2000, then the answers becomes too long-winded and doesn't make sense. This is really where you can again experiment. You start playing around with these parameters, start playing around with the LLMs that you're using, and start seeing what the benefits are. So what we normally do, or what we can do in this scenario, is create this class object. Once we've created that, we will just test it over here. So I ran this test earlier, like I mentioned. So let's say we're using GPT-4 Mini in this scenario, but we can also change this quickly to GPT-3.5 Turbo. This is where it becomes a lot more easier, where you start setting up your code to help you swap in and swap out these LLMs really fast, or changing the parameters like temperature as an example to test. And once you've got that code set up, you're going to make changes a lot faster. So yeah, I just set this thing up. I asked the question, how do I set up my printer? And it gave me this very random answer in terms of how to set up a printer, which looks pretty standard, but I guess that's not the point of this demo. The point of this demo is to show that how do we set the code up and how do we use MLflow to log and register these models. So now we want to log it. And a similar sort of process as what you've seen before. We set the experiment. As you can see, I changed the name. It's not the MLOps demo experiment anymore with the date. I just gave it a different name for demo purpose. But we start the run. We still do tagging. We log our parameters for future use. And we log the model. Previously we had the XGBoost over here, and now we're saying let's log this chatbot LLM object that we created above. Same sort of principles here. It's going to give us this very interesting name, a unique name that we can identify, and we can go in there and see who created it, when did they create it, what all the parameters, what engine was used. So again, quickly to get back to what was used for this particular experiment. Just to jump back here. And similar sort of process where if we wanted to, in a different environment, if we wanted to load this model, as long as we have this run ID, we can create the model URI and call it and send a predict, call the predict function within that and get an answer. And that shows again the capabilities. We play around with these run IDs. We do different experiments, and we know which ones we want to test. We can swap in this run ID and change it for something else. And in this case, I just asked it a really old school question: how do I install my fax machine? I was expecting it to tell me it doesn't know what a fax machine is, but lo and behold, it actually gave me an answer. Start by unboxing and checking the contents, which seems reasonable, I guess, but at least it gave me an answer. So that's from an MLOps point of view. What we like to do from an Azure DevOps point of view, just to bring this all together, is one, from an overview point of view, just good practice that I like is model card, just writing down what this thing is for, why is it being used. Oftentimes your business units, your business analysts and business users might not go into the code so much, but they might go into DevOps and have a look at some of these things. And that's quickly going to highlight to them, if someone is working on a model that's not really relevant to any business processes at that point. But it also just gives you some some information on the performance of the model, what data was used, what's the maintenance plan, should we retrain or do we plan to retrain this thing on a quarterly basis, etc. Just some information there. But once we are done and we've made these changes, the standard process in terms of commits. So one thing I didn't show before, just to jump back quickly here, we often set up our workspaces. You'll see it's a little bit cut off here, but that particular workspace is our prod workspace. AI Fabric Demo Workspace prod, and that one will be the UAT. And what we'll have is let's say, a new user. We might set up a new user workspace with their initials, so that they can work there and not obviously fiddle with UAT. Once they're done, they do a commit. I've done this commit a little bit earlier. Standard things that you can see in any code comparison notebook, any code comparison tool, see where the changes are. You can obviously now set up within Azure DevOps, you can set up that gated approvals, making sure that if I make a change, it goes to someone, Greg has to sign it off before it actually goes into production, just to obviously alleviate any issues that might be popping up. But once we
quickly on that point, Hennie, Sam was wondering, is any of this code base available in a Git repository, or going to be shared?
The code base that I showed, it's not in a Git repository, but I can share with you a Git repository, Sam, if you want to. That's got a lot more information as well. Happy to do that, if that helps. Awesome. So you can see I've done a few commits, and then standard pull request process. I don't make a commit change right now. Let's maybe just quickly see if we can kick this off. Because we did make a change. Go here. We changed the date right at the beginning. So let's just see if that works while this thing is running. So also, as you guys probably know, Azure DevOps nice because you can do your code repos, but you can also set your do your agile processes, run your sprints, create your features, create your tasks, and link those tasks obviously to the commits to make sure that you've got the governance in place. And then once we are done with that, while this thing is running, I'm just going to quickly show this then. So we are in a user workspace environment. The user has now made changes. This is a dev environment. They've made whatever they wanted to. They've sent it as a commit. It's been approved via the pull request process. And then once we're done with that, we can come to this side of things. And within Fabric and using the deployment pipelines, we've got our MLOps demo pipeline here. And, in this scenario, we just got a UAT environment set up and connected to our prod environment. As you can see at the moment, I've already done this earlier today. So it's obviously in sync. There's no changes. But as soon as we get all of this stuff run, we should be able to see that change inside DevOps. Let's see how quickly this can run. And while I'm waiting for this to run, is there any other questions or comments so far?
Not seeing anything just yet. Oh, Emmanuel's asking, do you have a capacity dedicated only for the ML training and usage? Or are you sharing capacity?
So normally we'd set up the capacities for at least the dev and the prod environments separately. Data science is quite an interesting one normally because the training often takes the larger capacity. I know it's not often the other way around for general software development. But normally within your training environment or within your training exercise, that's where you're running multiple models, multiple data sets through it. Inferencing is often a lot smaller, especially if you run, let's say, a batch inferencing process. You build your model, now you just apply it on a monthly basis to that data. It can often be just a lot smaller. But yeah, we normally split those capacities, but I don't think you need to. It's not necessary. That's really a company. It depends on how many, if you have one data scientist working on your environments, that's a different story to having 2,000 working on the same environment. Awesome. So we have now made a change. So what we can do is just go back to the workspace and click on source control. Sometimes it automatically updates, sometimes it does not. I have to refresh it quite a few times. UAT, that's why, that'll help if I get to the right environment. So there we go. So I made some changes. Obviously the changes we just saw. So what I'm going to do over here is just commit this. And as soon as this is committed, we can come back to the DevOps, have a look at the commits. So there's my commit just now. Commit one item from the workspace. And as you can see here, the only thing I really changed was that date became 26th. Obviously, if there's a lot more changes, this will look a lot different. But once we're done with that, we go to the pull requests. We create a new one. I'm just going to leave that as is. And what this will do is it'll pull from the MLOps dev branch, which is, as you can see over here, when we work in this dev environment, that's what we're working on, and pulling that into main. And you can obviously now go and change this if you wanted to, but in this scenario, we are pulling it into main. And I know I'm not supposed to do this myself. Obviously, there will be someone that's supposed to approve this, but just for today's sake, for the demo, we approve it, and then we can complete this merger into the UAT, into the main branch rather. Give it a few seconds, and then that is done. And the next steps would just be to go into the UAT workspaces. Which one is that? This one. And again, make sure that the pipelines, so previously they were all in sync. Now we can see there's an update, obviously the update that I just made. And then I can click update on the updates, update all. And we have it synced. So just shows the process that I mentioned earlier, where you don't have to do manual refactoring of the code. I know we made a very small code change, but even if we made changes to the models and to the rest of it, same sort of process would apply. So now our UAT environment is in sync, and typically what you would do now is run your UAT tests. So you may have some automated test scripts set up. You'll run them now on this new code. It's in a different environment. It's segregated from the dev environment, and we see if we get the same results. Once we're happy with that, go to the deployment pipelines, and should see this thing being out of sync now. There we go. There we go. And so what we're seeing at the bottom here is our lakehouse is still the same. So we have the same data information, but our code is obviously changed. That small change that I made. And so what we can just do over here is, once we're happy, we say deploy from UAT, and we click on deploy and we say go for it. And then once this is done, we've just basically worked through a process of making a change in dev, promoting it to UAT, testing it, and then promoting that into prod without making a bunch of code changes ourselves. And that really speeds up the process from a delivery point of view. So I'm going to flip back to this and just go. So I think those are the practical steps that we just ran through in this demo. You know, the governance component of it, making sure the documentation is there, what I showed you in the wiki in Azure DevOps, making sure we know what the plan is for this model. Again, that template, that's just what we use or what I use. You can add there as much information as you want, but that at least gives you some sort of idea of what this model is used for, where it's being used, and you can add to that level of detail. The model registry showed how do we use MLflow to register these models and then load them again. Reusable code bases, if you think about that feature piece, the feature code piece, and similarly the models. Experiment tracking. Data science is a world of experimentation. It's gonna happen. It's part of it, and it's key to just make sure that we can log the results, we can log the experiments, we can retrace our steps, and get back to where we were before. Automated deployments, as we just showed. The gated approvals, I didn't demo that now because that would have been a bit difficult to set up, but obviously in DevOps, you will set those policies to say, well, it needs to go to someone else, to this person, and maybe someone else, another person after that, before it actually can be pushed to prod or to UAT or to prod. Time traveling between experiments using the Delta files helps us to time travel in a sense to be able to run different versions of input data with different versions of the models, which is a great thing to be able to do to test and to make our models better. We can reproduce our results, and I think the experiment tracking and monitoring, the UI within Fabric, that just gives you a lot of the experiment tracking capabilities out of the box, which is quite useful. I think that is my story for today.
That was quite the story, Mr. Hennie. Before we get into some questions that is in the chat, I would love if everybody could turn on their camera, come off mute. Let's give Hennie a round of applause for getting so deep on MLOps and AIOps in Fabric. That was awesome.